Let's look at geometric progressions now. So what is a geometric progression? A progression of numbers with a constant ratio between each numbers and the one before it. So what do I mean by this? Let's take a look at this example where we have 1, 3, 9, 27 and 81. So let's take a number 3 now and divide it by the number before it. I have 3 over 1. Let's take another number 9 and divide it by the number before it. Another number 27 and divide it by the number before it. And 81 divided by the number before it. As you can see, the result here is what? 3. 9 divided by 3 is 3. 27, so this is supposed to be 9. 27 divided by 9 is 3. And 81 divided by 27 is 3. As you can see, the ratio between a number and the term before it is equals to a constant number. In this case, that is 3. So progressions such as this we call geometric progressions. Another way of saying it is that these are progressions in which you are multiplying a constant number by term to get the next term. So in this case, we are multiplying a term by 3 to get the next term. So you multiply 1 by 3, we get 3. 3 by 3 gives us 9. 9 by 3 gives us 27. 27 by 3 gives us 81. So this is what distinguishes geometric progression from arithmetic progression. In arithmetic progression, we are adding a constant number, but in geometric progression, we are multiplying a constant number, and that constant number is referred to as the common ratio. So this can also be written as, this expression can be written as 1. 3 can be written as what? 1 times 3 raised by 1. 9 can be written as 1 times 3 raised by 2. 27 can be written as 1 times 3 raised by 3, and so on. So how do we write this in general? So in general, a geometric progression is given by a comma, then you have the first term, a is the first term, a times the common ratio. Then the second term will be the first term times the common ratio, the second term, which is ar, times the common ratio again. That is why you have ar squared. Then the fourth term will be the third term times the common ratio, which gives you ar cubed. And the common ratio is gotten by dividing a term by the term that comes before it. So you can have it by saying either ar divided by ar squared divided by ar, or ar cubed divided by ar squared. So how do you calculate the nth term of a GP? So the nth term of a GP is given by this formula: un is equals to ar raised to power n minus 1, where a is the first term, r is the common ratio, and n is the nth term. So let's assume that we are given the progression, the geometric progression 5, 10, 20, 40, 80. We are told to find the nth and the 47th term. So let's start out. What will be our nth term? For the nth term of a GP is given as what? ar raised to power n minus 1, where a is the first term. So here the first term a is given as what? 5, and our common ratio will be what? 10 over 5, which gives us 2. So 10 divided by 5, or you can say 20 divided by 10, 40 divided by 20, 8 divided by 40. Any two numbers that you divide that are consecutive, you get the same result, which is what? 2 in this case. So our nth term un will be given as, the first term is 5 and the common ratio is what? 2 raised to power n minus 1. So this is the formula for calculating the nth term. Un is equals to 5 times 2 raised by n minus 1. So the B part of the question asks us to find the 47th term. So here n is equals to 47. So what do we have? U47 will be equals to 5 times 2 raised to power 47 minus 1. And what would that be? 5 times 2 raised to power 46. Now 2 raised to power 46 is a very huge number, so we are not going to evaluate it. We are going to stop here. Let's take a look at another example. We are told that the first, second, and last term of a GP are 162 minus 108 and minus 21 number 1 over 3 respectively. They were now told to calculate the number of terms in the GP. So as I've explained before, the number of terms in the progression is the same thing as the nth term of the last term. So all we need to calculate is what term is the last term, and that gives us the number of terms that are in the geometric progression. So we start out, we are told that the first term a is equals to 162, and we are told that the second term, which is ar, is what? Minus 108. So we can find our common ratio. Our common ratio will be ar over r, and in this case that will be what? Minus 108 over 162. As you can see, the first and the second term are consecutive, so we just divide the second term by the first term. And if you divide both sides by 24, or you reduce to the lowest term, you get minus 2 over 3. So our common ratio is minus 2 over 3. Now, what is the formula for calculating the nth term of a GP? The nth term of a GP, un, is given by what? Ar raised to power n minus 1. Now, we are told that the last term, u of the last term, is equals to what? Minus 21 over 1 over 3. And we can change this to improper fraction, and that will be 21 times 3, which is 63, plus 1, which is 64. That will be what? Minus 64 over 3. So we can substitute what we know into this equation and get the value of n. So now, substituting it, we have what? Minus 64 over 3 is equals to, what is our first term? Our first term, a, is 162. Then multiply by, what is our common ratio? Our common ratio is minus 2 over 3, then raised to power n minus 1, in which we are looking for the value of n. So what do? We try to bring this over here. So we have what? Minus 64 over 3 times 162. If I divide both sides by 162, will be equals to minus 2 over 3 raised by n minus 1. And if I divide 2 here, will give me 32, and 2 here will give me 81. So that will result in what? So minus 32 over 81 times 3 gives me 243, is equals to minus 2 over 3 raised to power n minus 1. So now I'm just going to write this here and bring this here. So I have minus 2 over 3 raised by n minus 1 is equals to minus 32 over 243. Now, if I look at 32 and 243, I can write 32 in terms of 2, and I can write 243 in terms of 3. So what do I mean? So minus 2 over 3 raised by n minus 1 is equals to minus 32 is same as writing what? Minus 2 raised by 5. If I raise minus 2 to the power of 5, I will get minus 32. And if I raise 3 to the power of 5, I will get 243. So I can collect like times and bring the power outside to have what? Minus 2 over 3 raised by n minus 1 is equals to minus 2 over 3 raised by 5. And if you remember from our law of indices, when you have the same base, then that means the power must be equal, or the exponent must be equal. So I can just equate the exponent. So equating the exponent. And if you don't understand what you are doing now, you can just go through the videos on indices to understand better. So I have what? N minus 1 is equals to 5. So that gives me n is equals to 5 plus 1, and that gives me 6. So the last term here is the sixth term. So that means there are what? There are 6 terms in this geometric progression. So this sums up what you need to know, at least the basic idea that you need to solve geometric progression problems.